preview. Let's start streaming. Hit the button. Okay. Welcome again, everyone, to another episode of Dan Does Data. We're here tonight to continue this self-driving car study. The big issue is the race starts this weekend. And so, do we have a model that's ready? And the answer is sort of. I spent a lot of time last week off stream fiddling with the model. I essentially spent 2 days fighting with it, trying to make it better, and I ended up pretty much back where I started. And what I had to do eventually was throw out trying to model the gas, the acceleration of should you go faster or slower, or should you go fast or stop or go backwards. We had really imbalanced classes, and I didn't have the time to fight with that, to try to get more data, do it the right way. So I said, you know what, we're just, the new model is always try to go forward if you can. And if the car hits something and it's going really slow, it's not going to be a big deal. Just let's focus on the steering. So I did that. I was having other trouble. I had added dropout training and other things, trying to improve the model. I was having a heck of a time. I kept getting a model that was always the same thing, or it was doing really terrible. So I had to remove the dropout training and settle for a little bit of regularization. And so I have this model that I'm now calling Auto, because we have an auto tractor is what it's going to be. It's a little toy John Deere tractor. And so that's what this script here is, auto.py. This is what actually drives the car. And I just want to walk through this real quick. You'll notice I've got something training here on the left. We're going to get to that later. That is a model submitted by Isaac, another viewer and generally awesome guy who's been helping me work through some of these issues. I haven't actually trained the model yet. It's a considerably larger model in terms of number of parameters, or at least computation time. So it might take a little bit, but hopefully while I'm explaining this, we can see how that does. He reported that he was able to get significantly better loss. So I'm hopeful that I can try that, and maybe I can just substitute that in place of auto. It should be pretty easy here. Let me just walk through the auto here, though. It might not be super exciting, but it is like, you can't just have a model and do nothing with it, then you didn't really accomplish anything. So let's take a look at that. First of all, we need the usual stuff that we need to just interact with Python in an intelligent way. We need numpy, we need h5py to read our weight files, we need scipy because we need to read the webcam and resize that image properly and do some image processing. The way that this model is actually going to communicate with the vehicle is over a serial port. So the model is going to be loaded onto an embedded computer sitting on the tractor. And we have, it's called a Fubarino. It's very similar to an Arduino that sort of, when told, go this fast, turn this much, it sends the commands to physically control the car. It was rigging up automatic steering. It was a whole other mess that the other people on Team Fubar really did a great job taking care of. But we're just going to be communicating over the serial port. We'll see what commands we need to read and send when we get to that. All this stuff, of course, is just the Keras stuff, as usual. Let me click the Reddit button. If you want to go over to reddit/r/machine learning, if you want to upvote this so other people can find out about it, that's great. I did see someone else had a live stream, I think yesterday. So that's good to see that other people are trying this out. I've imported sklearn for metrics here, but I don't think I'm actually using that. Don't worry about it. We've got date time because we're going to timestamp all of these, all the commands that we're sending and all the ones that we're receiving. And we're only going to timestamp them with like milliseconds since we started or something ridiculous like that. Then I've got this thing called pygame because I need to read the webcam. And on the embedded computer that we have, it's based on an ARM processor. It's this NVIDIA TK1 board. So it's got a GPU. It's pretty straightforward to use. It's pretty nice. But because it's an ARM board, not as much software is precompiled. So OpenCV, Open Computer Vision, is what you might normally use to control things in Python. However, we had to deal with pygame. Pygame is a little bit easier to install, a little lower requirements to install, and actually, I have not installed it on this computer. So I need to do that right now. So we're gonna go ahead and do that. Install pygame. Pygame lets me grab the webcam in a very simple way. That's all that it's for. You can use it to do all kinds of other things. I haven't actually used it that much. Downloads, pygame, installing pygame. I don't want to install from source. There's a way to install. Oh, it's available through apt-get. How did I miss this? How did I miss this? Wait a minute, is it available for Python 3 though? That is always the catch. Let's find out. Python 3, pygame, Ubuntu. You don't have to build from source normally, but you do have to use Python's like setup.py routine is what I ended up having to do. Only the orphaned movie module, which I don't think I need. There's no pre-planned packages for pygame, Python 3, at least at 1404. Of course, this was several years ago. But let's sudo apt cache search pygame. Let's do that. Pygame dash Python dash pygame. We can try it. Sudo apt-get install Python dash pygame. Let's see what happens, shall we? I'm in favor of just seeing what happens. In this case, we're working with a computer, so it's very easy to just try something. And if it doesn't work, it doesn't work. That's great. We can go back and figure it out. But often it's less time to just try that than to try something else. Import pygame, no module named pygame. Okay, so that did not. It says it installed, but I'm sure it installed for IPython. For Python 2. And if I import pygame here. Yeah. So that is not what we wanted. Sudo apt-get remove. Let's just remove it so we can deconflict. There we go. Get rid of that. Don't want it. Only packages wrongly installed are no longer required. Man, I really hope you don't screw me. Meanwhile, Isaac's model is actually doing really well here. Great loss. The validation loss, 0.02. Not too bad. I was getting high 0.02s, low 0.03s in my model. So it's good to see that it's, I say, like, statistically better. And you know what? Even though it's taking longer in terms of time, it hasn't taken as many epochs. Anyway, we're getting ahead of ourselves. We are installing pygame. Pygame, compile Ubuntu. You can try this PPA. I don't want to try someone else's fancy PPA. I know there's a not rocket science way to do this. I gotta install Mercurial, that's right. That's right, that's what I gotta do. Let's CD downloads. Do I have Mercurial already? Probably not. Let's find out. I don't. So Mercurial is an alternative to Git for version control. Several years ago, I don't know, like 5 or 6, they were probably on par. Rick, you made it to the stream. Congratulations, welcome. Rick Anderson has been working extremely hard, way harder than me on this this tractor, trying to get everything ready. And he's going to tell me if I screwed up the serial communication routine. I put it at 50-50 whether I screwed that up. Right now, however, I need to install pygame. So I need to install Mercurial to install pygame. Apt-get install Mercurial. There we go. Okay, so that's Mercurial. And we're going to clone this repository of pygame so we sort of get the latest. I think they use Bitbucket. I don't know why they choose to use Mercurial over Git. It might have been that's what they used then, and it's just easier to stick with what they have. It's not really a big deal. CD pygame? Can I just do that? Yes. Nice. And then we need to build it. And I need to build it for Python 3. Here we go. Ding. So you got to build it first, and then you install it. Whoa. SDL config not found. These are just warnings. Make sure development version of SDL is installed. So I thought I had all this stuff. Oh, but the SDL I might not. So you need SDL is a relatively low-level library for just making simple graphics in a GUI in Linux. I fiddled with it marginally. I've used SFML more, which is slightly higher level. It's simple fast media library. SDL, I don't recall what it stands for actually. Sudo apt-get install. This is sort of what happens when you want nice things. Let's just grab all this, anything marked SDL. I probably have a bunch of it already. I probably have a bunch of, and this other stuff I'm not as worried about. Rick says nothing to report. Be available tonight and tomorrow. Excellent. Rick, I thought you were driving out tomorrow for the race this weekend. Either way, I'll be working on this tomorrow as well, and we can always upload remote solutions. All right, this should be good. Let's do Python 3-OpenGL. That sounds like a good graphical thing to have. 36 megabytes, no problem. I love the future where like downloading 36 megabytes takes almost no time at all. This is fantastic. Like I grew up on dial-up. Oh, it's horrible, horrible. I distinctly recall trying to download some program that was like 200 megabytes, tried to do it in a week. My friend just mailed it to me. Much faster, much faster. I've probably told that story before. That's how common it is. All right, this other model's pretty. It's getting better too. Well, it's the validation loss is kind of leveled out. That's okay. It's Python 3 setup.py build. Yeah. Setup.py build. There we go. Some pygame dependencies not found. I don't really care about fonts. I don't care about minis. I don't really care about this other stuff. I only care about reading images. That's the only thing that concerns me right now. Do some compiling. It's issuing warnings, but I'm not too worried about that. We should be able to capture images. So I just need to verify that I can capture the image. This is what I had to do. What is it? I think Sunday I did this. I was at Fubar, frantically trying to create this script to drive the car. And then of course we got to install it. Oh fudge! What did I do? No, we're fine. Thought I did it for Python 2 for a second. Yeah, there we go. Make it go. So this should be everything. And then I should be able to say Python 3, import pygame. Okay. Actually, let's... So there's pygame, there's pygame.camera, and there's pygame.locals import. Slimux REPL configure. So I'm going to send to a different... Burned myself there. I would no longer like to send to the left. I want to send down here briefly, so I'm reconfigure my Slimux temporarily. There we go. So you have to import pygame and pygame.camera separately. It's one of those things that I hate. If I import pygame, I ought to have pygame.camera automatically. And you have to do a couple other funky things. It's pygame.locals import star, and you have to initialize it, and you have to initialize the camera. Whatever. That's all. That's just whatever it's going to be. I'm going to come down, skip all the model stuff for a second, just to show you how you figure out how you get something from the camera with pygame. So you get a list of your cameras, your webcams that you've connected. We've got dev/video1. That's the one with my face right now. And I'm going to take a 64. I'm going to initialize that camera. Excuse me. It's going to tell me that it's a camera dot get size. It's claiming that's actually going to give me 64 by 64, which is nice to know. You turn it on. No supported formats. Well, that didn't work. Huh. No supported formats. All right. This isn't a big deal because it works on the actual computer, actual machine that drives the car, just not mine. Pygame camera, no supported formats. There we go. What do I need to install to fix this? Take a snapshot from webcam, blah, blah, blah. Does it appear as? And it might be that the webcam is already in use by streaming. That might be why I'm not allowed to use it. Not taking a screenshot. Come on. No supported I really thought this would be a more helpful. Works a treat with my Logitech Pro webcam, yada yada yada. Can you change the file and change the file name extension? That shouldn't matter. Not reading a file. Increasing the resolution is brightened up. That's not what I'm looking for. Let's see. Again, this isn't a big deal if this doesn't work, but I would like to be able to demonstrate the model running. No supported formats. Yeah. But see, but I know my USB webcam works because it's working right now. So this is a problem with pygame, 100%. With LSUSB, I mean, something that pygame might depend on. Cover the common ones. So that's not going to help. When I ran to install this, I guess I could have tested it. Jeez, oh man, stuff, yada yada yada. Jeez, oh man, so much stuff. Ugh. Can I make test? Is that what I want? Or is the problem that I'm in the pygame directory right now? That shouldn't be the problem. There's a lot more than an SDL binding. Yeah. And nothing there. Okay. Yeah, let's just Python 3. Let's just do this. Let's just try running a test. Doing some stuff. Whoa, invalid syntax. That's really strange. That I wouldn't expect. Shouldn't be an invalid syntax problem. And of course you get like this long ass thing. Oh my gosh. Buggy test results eval. Pygame test.font test. Right, because I don't have any fonts installed apparently. What cameras are listed? Any reason you might need to use sudo? The sudo was just to install things. The only cameras listed are /dev/video0. Yeah, which is the webcam that I have installed, which is almost identical webcam to the one that's on the car itself. That is, it's a cheapo webcam. I bought mine for like 35 bucks, maybe 20 bucks, I don't remember. It was a good deal. It's got microphone and video, so I called it a goodbye. It's held up for almost a year. Alright, so maybe I need some fonts here. Xfonts, lib, STL. I didn't get lib, STL, TTF2, which would be true type font. That's the magic. Sudo apt get install ink. There we go. Let's see how that does. And I might have to rebuild Python 3 setup.py. Let's rebuild it. Alright, maybe that's fine. Clean, is that an option? Build. Alright. Install. See how that goes. Oh, sudo. Ho. Try that again. Python 3. And let's see if we can get pygame working here. And if we can't, that's not the end of the world. In fact, that's not going to matter at all for the purposes. For the purposes of this computer, pygame doesn't really have to work. Because A, I could install OpenCV on this computer. I might have done that already. And B, this computer isn't the one doing the driving. Yeah, here we go. No, still doesn't like that. No supported formats. That's super strange. Super strange. I just don't get why that is. That's irritating. Pygame camera, no supported formats. How to stream with a webcam in Python. I'm not trying to stream with a webcam. I just want to call the webcam. No supported formats, video. Video. This is weird. Let's see if we can get some information. Show me potato salad. I'd really like something from like Stack Exchange. That would be ideal. I was hoping they would just come up, but results and errors. Oh, it says simple CV. Oh, simple CV is another That's what I almost used. A simple computer vision relies on pygame to handle its webcam stuff. That's what I found first. And then I said, this is silly. I don't need all of simple CV. I just need the webcam. Enable. No supported formats. Yeah. Yeah, mine just has just very simple error here. Simple yet cryptic. What does someone else? What do these people say? Debugging a camera today, you should require good bit of information, yada yada yada. To unplug the camera and plug it back in, but I know that's not the problem. The camera is working fine. Geez, or Skype detect camera, others times not. Interesting. And it's right there. Dev video is right there. Bummer. This is exactly the kind of problem I have. Your camera only outputs JPEG frames. It's not currently supported by the camera module. Support might show up in the future. That's weird. Number of cameras don't work if it's whatever backend. Yeah, so this guy's using OpenCV instead. So use OpenCV to have for pygame to read. That's insane. Oh gosh. That'd be such a headache. I don't want to do that. I don't want to do that at all. Pygame.camera.camera. Can I say what kind of... Yeah, well, I was hoping that I could have more input onto the format. Instead of RGB, I don't know. Was it HGV? Is that some other one? It's probably not going to work. Yeah. Get raw, get image. It's not going to work. I highly doubt that's going to work. It really shouldn't, because you should have to start it first. Could be that I'm trying to stream at the same time. And seg faults. Good times. Alright, well, you know, we'll get back to that. Damn. So I get for trying to... I can't use arrows to navigate my Slimeox here. I have to use the Vim, like J and K keys. Alright, we'll come back to that. That's something that we will come back to as possibly interesting. For the moment, let's take a break from the auto tractor. Essentially, it loads in the model, it reads some serial information about the state, it loads the webcam image, it computes what it needs to compute, and then it writes some information back to the serial port about which way direction we should steer, how fast we should go, etc. I want to look at the model submitted by Isaac, who's another really sharp data scientist who's been watching the stream for a few weeks and leaving some really helpful comments and some really helpful emails. So he took my initial starting script and data that I compressed, and he reads it into this model, which is considerably simpler in concept, I think. You'll notice he's using this sequential object, which is sort of the straightforward way to use Keras when you don't have a fancy graph, when you just have one set of inputs and one output, or one series of outputs if you're trying to predict, say, 10 classes or 1 of 10 classes. But you're not trying to predict, like, gasoline output and steering. He's using sequential, and the way he does this is he uses sequential to set up the image processing, then he uses sequential to set up, and then he sort of adds in the other inputs in this merge layer right here, which I thought was really interesting. I didn't know you could do this. This to me was super cool. Let's just very quickly walk through this model, and then we'll take a look at how it did on the loss over here. And I don't know if he trained it for exactly this long, but that's about how I was comparing my model, so that seemed a reasonable thing to do. Oh, so he starts to drop out right away. He just throws away some of the... Well, he doesn't throw away. The dropout's 0%, but potential to just throw away input variables, which I think is interesting. That's an interesting idea. I hadn't thought about that. He's doing a lot more initial channels on the image. One thing you haven't noticed yet, he's only got, I should call this out more specifically. There's 1 here instead of 3 channels to the pixels. He changes the images down to grayscale to save on a lot of computational time and cut down the number of parameters. I didn't do that. I wanted to see if color mattered, yes or no. He might have already did that and determined, color isn't really that important. You'll see where he does that in a second. But he does this convolution with 32 kernels. I had like, let's see, we can even look here what I started with. I think I had like 6. Yeah, I have 6. He goes all in, says, all right, give me 32, compute 32 high-level features on this data. He's using simple ReLU instead of my my exponential linear unit. That's not a big deal. I was having tough luck with ReLU, but I'm glad to see it's working for him. He does 2x2 max pooling, typical stuff. Then he passes into another convolution with ReLU, and this time he computes 64 features based on those original 32. And that's it for the convolutions. And he does the max pooling and he flattens down. And what he does here is he makes the second part of the input, which would be the steering, or not the steering, excuse me, the speed and the acceleration right here. And so that's just this keras.layers.input layer, which I hadn't seen before. So this is super cool to know that you can stay a little more sane. The sequential model is a little bit easier to work with, a little bit easier to use. I don't know that it's actually going to be any faster. It should be the same graph in the end that we're computing, so that shouldn't be a big deal. And notice these are all model A. Oh, excuse me, model A right there. And these are all model B then. So those are 2 different types of inputs, the images themselves and the speed acceleration vector. And then he makes a third just model here with a new sequential, and the first thing he does, he just says, hey, merge those 2 previous models that I had. And you can do that in the sequential model. So that's super cool to know. And then he just throws a couple dense layers here. Again, 128 nodes. He's willing to go much bigger nodes than I was. I probably tend to stay on the small side and stay too small. And then he goes with this 32 nodes here, and the final node, of course, here with the linear activation. And Isaac said he came up with this. He started very simple and slowly built his way up, adding layers when they seemed to improve the model and not when they seemed it didn't. So I'm always curious how other people tend to work with these things. It's like I don't have a fixed way of how I do it yet, so that's interesting to me. Let's make some predictions. Error checking. Expected dropout 1 to have 4 dimensions, but got array with shape such and such. Boo-hoo. That's because he wants images gray and then speed. That's what I get for not... There we go, speed X. So this should take a little bit of time since this model takes a little bit longer to compute, but I'm sure it'll be plenty fast. And in fact, we can also... Oh boy, oh boy, oh boy. Grab some animation. And we come down here. I didn't need all that. Whoa, wrong thing. Okay, here we go. Didn't need all this. Maybe we'll get around to showing that later. Don't know for sure. Next frame, yeah, that all looks typical. Let's set val index to be 0. Not worried about that right now. Not gonna worry about it. Not gonna worry about it. Steer creds. Oh, there we go. Oh, that's not the kind of image I wanted to plot. I should just like delete that from all memory. In fact, goodbye. You're gone. That's the kind of image I wanted to plot. Interesting. Okay. So again, green is the actual model. And this is all the data, so we're used to just looking at the last chunk. And this is the data. It's all been crazy shuffled, I think. Yes, I believe it's all been crazy shuffled. So green is the actual data, and blue is the target model. You can see it's doing a pretty good job of staying in here. I don't know how well it's going to animate since... Yeah, it seems to be doing a pretty good job. It's not like... It's hard to tell now when it's all been mixed up like this. How mixed up has the data been made? Well, I guess if we could just reread in the data, right? Yeah, we could just reread in the data. Wouldn't really matter, right? Yeah, let's do that. Read in the data in the original order, and then I'll recompute the predictions. There we go. And then we'll see with these. Hopefully, it's a little more straightforward, I hope. And we can still use the color images to view how things work. We don't have to use the black and white. So that part doesn't need to change. Man, these predictions always take a while. But again, we're computing like 20,000 things. So if that takes, even if that took 1,000 seconds, that means that I could get 10 done in a second. And it doesn't take 1,000 seconds. It takes maybe 100, probably less. 100 would be a little under 2 minutes. I bet it's more like 30 seconds. Oh my gosh, that's misery. So how's everybody doing? Having a good night? Cooling down a little bit? Alright, there we go. Got our predictions. Make those. Yeah, here we go. Again, green real data, blue is prediction. And this is actually not too shabby. What's going on here where the real data is... that's actually harder to see. Let's grab here to here, say. Boink. Yeah, it's hard to tell, but there's some periodicity in the data here. And you see the blue's kind of up here, blue's kind of up here. Not too shabby, not too shabby at all. There's some unusual behavior wherever this is happening. Here the car's making some bad decisions, but you know, this is just going to get clamped to 1, so that's not really a big deal. I don't really care about it. That's not a problem, as far as I'm considered. Let's do that. And let's see if this works. Yeah, there we go. Red is what the model is predicting. As always, green is the real world. And it's still a little shaky. But that's not too bad. It's bouncing around the real result here. So that's always what the interesting thing is. I apologize if the stream is kind of jumpy or cutting in and cutting out. I have to work that out with my internet service provider, which is the devil. That's okay. I often like to just watch this for a little bit and see all right, where is the model doing a decent job? Where is it terrible? I could also add to this plot what is the speed and the acceleration at this time. You could have a little speedometer even. And you could have just a little bar telling you what the acceleration is. But that's ultimately this image is what I'm most interested in. Given this situation, how do you respond? And this is not half bad. That's cool. Yeah, going through that tunnel. I don't know why it likes to turn left so much. I don't know what the deal is. Maybe it thinks the tunnel, the tunnel is the same color as the road. And if there's road space to the left, you sort of turn that way. For a situation, I think it's coming up, there's this left turn. This is the part where we're stuck on the motorcycle, which is really irritating. Out of the way! Out of the way! Ugh. And we blitz through a car, there's a truck, you get caught on briefly. Yeah, now I've watched this whole video 10 times. I'm very familiar with it. Somewhere there should be a left turn coming up. Maybe not. Maybe I lied. Yeah, I opted not to remove those scenes where you briefly are stuck in the car, deciding that was a reasonable enough thing that could happen. Alright, well, that's going okay. They're in the tunnel again. This tunnel, it wasn't going as much to the left. Okay, that's fine. So again, that was Isaac's model. And he did pretty well. Yeah, the final validation mean squared error 0.198. That was definitely better than what I was getting. I was getting 0.25 something. Yeah, that might have been my best. And in a similar amount of time training, just looking at like 10 epics or something. If you train for a super long time, you might do better, you might do worse. His model, I didn't see any regularization. That might be something to consider adding. But if it's doing a good job as is, you know, don't fix what isn't broke. So that's super good to know. So I should definitely consider in the future fewer layers, more nodes. Just suck it up and do it, or start there maybe, rather than fewer nodes and more layers. Honestly, the more nodes on the fewer layers, that makes more sense. That I don't need to do as many transformations of the data as I really think. Because if you look at it here, you're putting in the speed and acceleration here. Those are only going through sort of 2 hidden layers before you get to the output. So that's not an insane number. That's a relatively shallow neural net, still technically deep. If you just had 1 layer, you would still get a lot of power out of that. We are doing this convolutional thing, but that's just to find the interesting features in the image. So that can go either way, really. So that's this model. I want to thank Isaac again. Give him a special shout out for sending that in, having the idea to just try the grayscale images. I don't know if I'm going to be able to work this in for the race this weekend. I kind of want to see what happens with the model that I had, just to see how it does in a real race. But I will definitely, for future models, be integrating these kind of ideas. So, and if you have your own model, the data is all on GitHub, so definitely take a look at it, try something out. I sort of have an idea I want to get to one day of like Twitch plays machine learning, where I just throw a problem with the data out there and you guys decide what the model is. We'll see how we get around to that and what a proper way to implement that would be. Because you don't want to have to make people just type. That's a terrible thing to make people do. But have a way to just say, oh, add a layer here, change this activation, do this, do that. We could try that manually at some point. That might be fun. And then just let it train. All right, so this has a problem with pygame back in the auto tractor. If you've ever seen Airplane, it's awesome. If you haven't, go watch Airplane with Otto the Autopilot. Fantastic movie. So why doesn't pygame... I'm really suspicious that pygame is not working. Really super suspicious. I'm tempted to do this. I'm really seriously tempted to just install OpenCV and tell pygame to use OpenCV. But I doubt I have Python 3 OpenCV. Let's see if I do. Nope. Of course not. People only using Python 2. Curse you. Problem with camera. Pygame plus webcam. Oh, that's in Spanish. I don't read Spanish. That's not going to help. Seems to relate to the pixel format used by the camera. Works fine with GStream and Cheese, but not Camera and MPlayer. That's so strange. This is just so weird. Like, I just have to imagine that the problem is... that the problem is that I haven't installed the correct support libraries. I feel like that just has to be the problem. Because I did not install all these things. You know, but let's go whole hog, shall we? Yeah, libav codec, libav format, AV, MIDI, MPEG, resample, all this other stuff. Xfonts and Xfonts Cyrillic. Gotta have those. 182 megabytes. Okay, this will take a little more time. Still, this is amazing that we're... What is this? Fluid sound font? I don't even know what that is. Should have taken a closer look. That's taking up over half of this. Alright, so while that's going, let's explain a little bit more of what the auto model is. So you guys, I don't think I've actually seen this model, since I fought with it so much last week. So let's just go over what it is real quick. It should be very familiar. We, as usual, have our real input. 1 second. Sorry about that. Have our real input there. That's again speed and acceleration. We've got 3 channels of color on our image from the webcam of what the car is going to see. And then we get into the actual model. I only have 6 kernels, 6 nodes on this first convolutional layer of 3x3. I think Isaac, he's doing 3x3 as well. 3x3 has sort of become the popular thing to do. It's sort of determined like, whatever you can do with a 3x3. And if you need to add more layers to figure it out, that's what you do. So we do that convolution on the image. We put it through an activation of an exponential linear unit. And then we do max pooling. Is that? Yeah. For a second, my brain was trying to convince me that I need to do max pooling before the activation, but that doesn't make any sense. So that's good. Similarly, we have another convolutional layer that just gets its input from the previous layer. Now we've got 8 kernels. Same activation, same max pooling. I have dropout listed here, but I don't actually have dropout percentage is 0. What did I do? Oh my goodness. And finally, one more convolutional layer with 16 kernels this time. Again, 3x3, exponential linear unit, max pooling, same sort of null dropout. We flatten those out so we can merge them with some other stuff. Other stuff mainly being the speed and acceleration vector. And again, I'm using the graph construct, so I'm just defining nodes that I will then just have my model say, hey, take these nodes as input, these nodes as output. We do the merge, and then I have 2 dense layers until I get to the output. I've got 32 node and then a 64 node. Again, I'm using the same exponential linear unit everywhere. And then I finally got the steering right here. Again, 1 node, linear. I name it so that I can access it more easily later. And then we got the model. You say, hey, take these things as input, take this thing as output, using the atom optimizer, and you do model.compile. And we're using mean squared error since it's a linear, we're trying to predict a number, not a probability or set of probabilities. I've pre-saved some weights, and I believe I've uploaded these to my Google Drive page or whatever that's linked off of GitHub. We would read in the camera state right here, we would start up the camera right here if we could do that. We're having some trouble though, so we'll get to that when we get to that. It should let me slowly get to that. Then we gotta make the serial connection. So I have some debug here. I've got just a test file of data of the correct format. And I didn't keep that data here, so I'd have to go look that up again to figure out exactly what that is. But normally it will just say serial.serial to open up that connection via the serial port. And actually, what happens when I try to do this? Serial is not defined. Oh, I didn't import serial. So what happens here? yeah, I didn't think that. There's no reason for that to exist on my computer now. Deb/gty. Yeah, of course, I don't have a USB modem with a serial port interface. So I can't actually open that on this computer. And that's what I wanted to look up. Well, how do you test this without an actual serial device? So how do you set up a fake one? And so you can just open up a file that you can read from, if that's what you want to do, or read and write from even. I initialized the speeds to 0 here because it turns out we don't have a great way to measure our absolute speed. Trying to get all the different modules that need to go on the car, getting this one is getting to be kind of tough, and I decided it was just not that critical. We need to focus on other things. So I'm going to initialize the speed. I'm going to try to track it over time with the changing acceleration. Maybe that's wrong. Maybe I should just say, meh, speed's always max. Because we're just always hitting the gas full throttle, so the speed should always be max. But we'll see. We get the initial time with this datetime.datetime.now. So, in the way that works is that gives you this actual date object. And if you want to say, well, that was the start, this is the stop. If you take the difference of two date-time objects, you get a time delta object. And in a time delta object, you can say, what's the total number of seconds? You might be thinking, oh, that microseconds looks good. That's what I want. I want a very nice resolution. We have an issue. The steering is not quick, according to Rick. That could be an issue, or it could not be an issue. It steers, but is not fast. I think that's not an issue. I think that just means we just update the steering once a second or whatever, or twice a second. Rick, how fast? Let me just say this in chat. How fast can we steer from full left to full right? That could be interesting. So anyway, this time delta, you might think microseconds is what you want. You say, that is the difference between these two things. Except you'll notice this is 176,000 microseconds, which is like 2/10 of a second. And there was definitely more time than that between these two objects. In fact, it was 9 seconds and this many microseconds. So if you say td.total seconds as a function, excuse me, then you get the fractional seconds. And we wanted milliseconds, so we're going to take that and times 1,000. That's how many milliseconds we're between. Oh, this is interesting. According to Rick, we can steer 3 seconds. Well, that will be interesting. That will definitely be interesting. So the reaction time of our vehicle, not that great, it turns out. Had to slow down the car to match the steering. Well, we'll just have to deal with the steering being what it is. If the steering is only once every 3 seconds, that is what it is. We'll read the state once every 3 seconds. The model will report back what to do. And we'll be driving slow. That's quite all right. That's quite all right. Yes. Okay. Then, continuing on in what auto is doing, there's this function to create the string that we send down the serial port. And to do this, yes. So we need to tell the car to drive, we send a string to the serial port. And the way we do that is we send a byte, essentially, a byte value, 0 through 255, that tells you which direction do you want to turn. 0 being full left, 255 being full right. You'll notice there's not going to be an exact straight in that world. But that's okay. I'm not worried about that. Then we need to know which direction we want to drive the car, forward or backwards. Because of the simplicity of this model, we decided to throw out the gas, the acceleration problem. We're just always going to say, go forward, go straight. That's a 1. Then, how fast do you want to go, in terms of full throttle? So obviously, if you send a 0, that means you want to brake. You don't want to go forward. And if you do want to go full throttle, that's 255. Again, just a byte value. So we're always going to be sending 255. Simple as that. And then finally, we just want the time in milliseconds. So some number, probably in, I guess it really shouldn't be that many. Like 1/10 of a second, or maybe, 3 seconds, depending when we get around to it. Even if the car, it takes 3 seconds to go from full left to full right, we don't often do that big a change. Usually we're going straight and we want to turn right, or we're going straight and we want to turn left. So 1.5 seconds, should be interesting. Should be interesting. The alternative, I think, is to ignore that problem and just say, well, the car needs to try to turn as best it can. And if it's not able to turn as much as it wants to, well, then it turns as much as it can and it does what it can. Hopefully that means it will still want to turn in the next frame, because it will still be looking at that image and say, I still need to turn to the right, because it's going to be looking at more or less the same image with the same inputs. So anyway, you return this as a formatted string with Python, And that's the string we're going to send through. All right, I made this do loop. I made a function for the overall loop of the model, what it does, just so I could time it. Again, I've got this global speeds array that I'm updating all the time. That's what that is here. The first thing you do is you grab the camera image. And that's with this pygame.surf array. I believe that's surface array.array3d because it's in color, I believe. And you call that on the object returned by cam.getImage. Cam.getImage doesn't give you a NumPy array. It gives you this other kind of object. And in our case, it was like 320 by 160 or something. It was some strange size, so I needed to square it up. No, it wasn't. Oh gosh, did I screw this up big time? I don't remember what the size of the image that it returned now is. It wasn't square, and I needed to chop off 20. I needed to chop off like 20 pixels on either side. You know what? It should be this. Yeah, I don't recall if it was 140 exactly. But anyway, I needed to chop off 40 pixels in total. Is it like 320 to... It would have been 320 to 240, I thought. And if I chopped off 40 pixels, that's still not square. All right. It's not that big of a deal, because the whole thing gets resized back to 64 by 64. And you know what? I tested it, I looked at it, and it's actually fine. Was it 240 by 160? No, that wouldn't work either. Would have been like 200 by 160. 160 by 120? Maybe it was 160 by 120. That might have been what it is. Anyway, so I chop out those widescreen columns right there. Then we do the SciPy imager size. This should look familiar. This is exactly what we did when we were processing the data that we used to train on. Then we got to figure out what is our current acceleration and stuff. And that's where we do this serial.readLine. You read the line, which just gives you a line of text, whatever the next thing on the port is. Then I turn all those things into floats. They're comma-separated values. This is just some debugging information that we have in here. So we say, hey, this is the data that we saw. We compute the acceleration, which we have acceleration in x, acceleration in y, and acceleration in z. And we're actually getting forces. So the acceleration in z, I want to subtract out the acceleration due to gravity. I really hope that I'm on the ground. If I'm not on the ground, I've got other problems that this model is not prepared, not equipped to deal with. So I subtract that out. I'm sort of doing something hacky here. I am adding the current acceleration values to the speeds, sort of a poor man's iteration. If I said acceleration times the time delta, then you can sort of think of that as if you had this average acceleration over the time period, that's how your speed has changed. I'm just considering this as like one time unit, whatever that means. Relatively speaking, that should be fine. And then what I do is I just compute the scale overall of the speed. So I square each speed value. Again, I don't really care about the velocity, and I know my speed vectors and my acceleration vectors all orthogonal, so it doesn't matter what direction they're in. I just want an overall magnitude, because I assume I'm going basically straight, whereas, yeah, that's the simplest thing to do here. So magnitude, speed, magnitude, acceleration. You square it and you sum along the axes, and then you take the square root. Euclidean distance, that kind of thing. From the origin to whatever the end of the sum of these vectors is. And then you notice there's this to-do here. So really we need to rescale these inputs to make sense relative to the model that we trained. And what I think that means is the speed should be from 0 to 1, and the acceleration should be from 0 to 1. And really the acceleration should be like 0.5 if we're going straight, if we go standing still. Should be like 1 if we're going forward. But I haven't done that. And the optimal way to do this would sort of be like, well, what's the maximum acceleration of the car? Just divide by that, and then we'll be fine. But you'll notice here, I'm taking a magnitude, then this is 0, that means we're stopped. And so I'm not accounting for which direction I'm going here. So this could be problematic. It might be the kind of thing where we need to basically throw out both of these values and say, well, I'll just put it in average and it'll be fine. I don't know, that depends. I didn't take a look at how significant that was impacting the model anyway. But supposing that you had them scaled or that it's not a big deal, then you just make your prediction. You pass in the speed and acceleration, you pass in that image that you've caught on the webcam, and you get your output steering value. And then, because recall, we've been using this linear activation this whole time, you might remember, you might remember this picture. Some of these things, this is Isaac's model, but my model does the same thing, sometimes worse. It sometimes predicts greater than 1 and less than 0. And so the simplest thing to do with that is to just take those values and truncate them, or clamp them down, as I say here. So I say take the minimum of whatever the model predicts and 1.0. So if the model is bigger than 1, this makes it 1.0. And then takes the maximum of whatever that is and 0. So if we were initially -1, well, -1 is less than 1. So that a -1 gets passed on here. And then I'm saying take the max between -1 and 0. Well, that's a 0. So you clamp both ends. And then I rescale that output into the byte, that 0 to 255 value. And because in the model 1 means turn left, we have to fiddle with that and make that work correctly here. And then we take the time. We could just compute the difference, which I went over before. And we say, hey, compute the drive string, and we send that to the serial port. And then we do the whole thing again. Let me just go down to where we call that loop. Boom, right here. That's it. That's the whole loop. Just while true, just do this forever. And there's some cleanup, but there's nothing that says, hey, break. You could have special commands that come in along the serial port that say, hey, stop working, clean up, we're done. You could also have special commands on the serial port that say, hey, start working. But I think the way we're going to control it is the model is going to be trying to control the car as soon as we turn it on, but we have a special switch that only enables, that tells the car to actually respond to the model's commands at a certain point. That's sort of the go button. And similarly, we've got a kill switch that says, hey, stop listening to the model. The model's crazy. Because I'll always put a kill switch on any robot. Even if you're sure it's not going to be a kill pod, always put a kill switch on it. And that's basically how it's going to work. So that took me a long time to describe, so hopefully that wasn't too complicated. Again, we read in the image, the webcam image. We read in the data from the serial port that contains our acceleration information. We use that to compute our speed information and our magnitudes. We use that to make a prediction based on the actual machine learning model. We fix up that prediction if it's a little off. We rescale it for output. We figure out the time and we send it on out. And then we do it all over again. One problem is I'm not sure if when we read a line from the serial port, if that's going to be the most recent line. Rick says we have a kill button and an autonomous button. That's perfect. That's exactly what we need. Kill button and autonomous. Just to hit the autonomous button and the model should be fine. One problem when we do make the read line, that reads one line from the serial port input, the serial port. What if there's already like multiple lines queued up? And I don't have a good way to read a bunch of those lines. And unfortunately, we're also at about 6, so I'm going to have to end the stream here. But that could be an issue. One thing that may not make that an issue is that this whole loop on the board that we have takes like 40 milliseconds to run, assuming the model is already compiled. And so if you've got 1,000 milliseconds per second divided by 40, you can do this 25 times a second. And we can't even steer that well. So if we sort of slow down the rest of the system, then we shouldn't have a problem. There should only ever be one line here. And I believe this should block until we get a line. I'm actually not sure about that. That could be problematic. This maybe I should add some safe code in here that says, hey, keep reading until you get a line. Keep reading until you get a line with some content. If the line is empty, throw it out. So those are some things that we can look at to see what we want to do about improving the model. But again, this is the auto tractor is what we're calling it. And just for giggles, let's go back and we'll show the old. Again, this is what we want the auto tractor to do, right? Know how to steer. Yeah, this is able to respond in much more quickly than 1.5 seconds. Although this is actually sped up. This is an insanely fast speed that this is going. Oh well. I think that's all we got for tonight. I'm probably going to keep working on this. I know Rick is going to continue to work on things. We are racing, is it Saturday, Sunday? Somewhere in Colorado. I will not physically be there, but if you are going to the Power Wheels, the Power Racing Series, Power Racing Series, Fubar Labs is going to be there. Go on and say hi. Please cheer on. They will have other human drivers as well. I believe all these folks, Bill and Rick and Gene are going to be there. Here's their file photos right here. Bill's in space. There's Gene, and of course Rick is just a box. Rick is a black box, essentially. You feed him with coffee and other things, and he creates amazing things. So that's what we got. All right, that's all I got for tonight on the model. Next week we might do more of this because there are more races and there's more better things to do. Might move on to something new. If you have an opinion on that, feel free to leave a comment or shoot me an email. Let me know what you should do. All right, that's all. Don't forget to stay safe in the data mines.